Hey calculus kids, this is Dr. Callahan with week 17 Tuesday. How are you guys doing? Hope you guys had a good week so far. So here is your warm up. Go ahead and pause the video and answer the following questions. All right, so today we're going to go ahead and get started with one of the questions of the 6 questions that was released from the free response for 2021. But before you do that, I just want to briefly kind of go over a few things with you guys for this week on certain due dates. So this is week 17, and so 17 Monday, Tuesday, and Wednesday, you need to go ahead and start Unit 7 on differential equations and slope fields for semester 2 on our IO. There are 100 questions. Out of the 100, you can pick any 30. If you need additional assistance, your print and review on page 357 to 367. And then on Thursday and Friday of this week, you need to start Unit 8, which is an application of integrals with area and volume. So that one, it's 107 questions, but feel free to pick any 20 questions of your choice. And if you need assistance, your principal review is on page 317 to 354. So this is kind of the breakdown of what we have left. You guys have your finals on the 8th and the 9th of June. Your AP exam for 2021 is going to be on the 24th, which is week 19 Monday. And this is week 17 Tuesday. So you have roughly about 3 weeks. All right, so if I did not see you guys in person on week 17 Monday, which was yesterday, you guys need to grab this hard copy, which features the 6 questions, 2 with a calculator, 4 without a calculator. That was featured on the 2021 AP Calculus free response. So I have a video right here that actually showcases how to do all 6 questions. You can use a QR code as well. But here's question 1 and question 2 with a calculator that was given on May 4th, so last Tuesday. And then question 3 and 4, we actually went over question 3 on Monday. So if you need to figure out how to do this question here, make sure you watch week 17 Monday's video. And then questions 5 and 6. So with that said, let's go ahead and go over question number 1. This one you are required to have a calculator, so make sure you guys do have one. And take a moment and read the question itself. Okay, so let's go ahead and take a look at part A then. So A asks you to use the data in the table to go ahead and estimate f prime of 2.5. Well, f prime is going to be the slope, which is the first derivative. So naturally, if you're looking at 2.5, the 2 points you really should look at is going to be, well, you do have 2.5 right here, but you also, I'm sorry, it's not 2.5, it's 2.25. I'm like, if it's 2.5, I'm like, well, what's the point of finding it? It's right there, it's 10. Anyways, so 2.5, the number that's between 2.25 is going to be 2 and 2.5. So that's going to be your x1, x2, and then your y1, y2. So your slope formula is going to be f of 2.5 minus f of 2, 10 minus 6, or hold on a second. That's not correct. Not 10 minus 6. That's going to be the y value. The x value is going to be 2.5 minus 2. There we go. Which is equal to the y values f of 2.5 is going to give you a 10 minus f of 2 is going to give you a 6. 2.5 minus 2. So that's 4 over 0.5, which is going to give you 8. Now with the 8, you have to remember your units. And so what we're going to do is we are going to go back to the original equation or the question and see what the unit is going to be. And given the fact that they're asking about density of bacteria in a petri dish, it's measured in milligrams per square centimeter. So that's what I was looking for. So I'm going to go ahead and put milligrams per centimeters squared. So then at the same time, it's asking you to interpret the meaning of your answer to the context of this problem. So what you can say is, the question itself is asking about the density of the bacteria population. So you can say 8 milligram per centimeters squared indicates that the density of the bacteria is increasing by approximately 8 milligram per centimeter squared at R equals 2.25 centimeters. So that is actually one interpretation. Another one you can say is at a distance of 2.25 centimeters from the center of the dish, the density of the bacteria is increasing by approximately 8 milligram per centimeter square per centimeter. And actually it's milligram per centimeter squared, milligram per square centimeters. Okay. And that's sufficient for question A. All right, let's go ahead and take a look at question B. For question B, it says the total mass in milligrams of bacteria in the petri dish is given by the integral expression. So you have 2 pi integral 0 to 4 r times f of r dr. Approximate the value of this using the right Riemann sum. So we're looking at it at the right side of this with 4 subintervals indicated by the data table. All right, so then looking at this here, you're looking at r times f of r. So I'm going to extend that as the next row. So in which case, what that means is r times f of r is, here's r, here's f of r. So that's 0 times 1, which is 0. 1 times 2 is 2. 2 times 6 is 12. 2.5 times 10 is 25. 4 times 18 is going to give you a 72. And that's important to have because remember this piece right here is aligned to this piece right here into the equation. From the right Riemann sum, you're looking at, okay, so what is the distance between 1 and 0? That's going to be 1. What is the difference between 2 and 1? That's also 1. Between 2.5 and 2, that's 0.5. Between 4 and 2.5, it is going to be 1.5. All right, so then that's going to be equal to 2 pi. To get rid of this integral from 0 to 4, we're going to have to do this with 4 intervals. So I'm going to do this 4 times, okay? So that's going to be multiplied by, so here is the first interval. Your first interval is going to be r times f of r, which is 0. 0 times, between the distance of 1 and 0 is 1. Plus, second interval, r f of r is 2. Times the distance between 2 to 1 is also 1. Plus, here's a third one, which is 12. And the distance here is going to be 0.5. And then the fourth one, which is going to give you 72, or excuse me, 25. And the distance right there is 0.5. And then here's a fifth one, which is going to be 72 times the distance of 1.5. But then hold on a second. I know you're thinking like, wait a minute, there are 5, but I really need 4. So because this is by the right Riemann sum, you're looking at the last 4. So I'm really looking at this one here, 1, 2, 3, 4. So you do not need to use this one here. So 1, 2, 3, 4 from the right Riemann sum. Okay, so then with that said, grab your calculator, multiply this part out, And then don't forget to multiply it by a 2 pi. So everything here, if you're to multiply it, is going to give you 134.5 times by 2 pi, which is going to give you 845.088 milligrams. And that is your answer. All right, let's take a look at part C. So part C says, is the approximation found in part B, which we found, an overestimate or underestimate of the total mass of bacteria in the Petri dish? So given the fact that we're looking at the right Riemann sum, the way I kind of look at this is like this. So the right Riemann sum, here's the right side, is going to be the estimation like this. And we need to have 4 subintervals. So then because it's from the right side, notice the overestimation in the spaces right here. But when you're actually justifying your answer, you want to go ahead and make sure that you're using evidence to prove that. So what you can say is, given that f of r is positive and increasing, because if you look from f of r, it's from 1 to 2 to the 6, 6 to 8, or 10, 10 to 18. It's a positive number and it's increasing. And it's a right Riemann sum. The estimate from part B, and again, I'm just going back to part B, exactly the wording they use. Or you could say from part B, the estimate or the approximation from part B is an over estimate. And that's sufficiently answered part C. All right, so for part D, it says the density of the bacteria in a petri dish for 1 to 4 is modeled by the function g defined by g of r equals 2 minus 16 cosine times 1.57 square root of r to the 3rd power. For what value of k that's between 1 and 4 is g of k equal to the average value of g of r on that interval? So then for this one, what you're looking at is you're going to look at g of k, and you're looking at it from 1 to 4. And you're going to be inserting g of r dr, and you have that equation right here. So you're going to plug this into your calculator. And given the fact that says the average value means that you're going to be dividing it by 4 minus 1. So another way of interpreting this is because it will be with the average value. Remember the average value formula is g of r is equal to, and this is the average value, is equal to, you're going to evaluate it, between 1 to 4 is equal to 1 over, remember it's b minus a, so here is a, here is b. So 4 minus 1 times the integral between 1 to 4, g of r dr. So on your TI-84, make sure you hit math, 9 for integral. Make sure on the integral you put 1 to 4. In the boxes, make sure you go ahead and put this formula in for that, and then put in dx, and then hit enter. And then what you should get is you should get the k value, or excuse me, you should get the g of r value, which is going to be 9.87579. And so then what you need to do in addition to that is you need to go ahead and this is going to be your y value. Whoops. If you want to think about it that way. And this part right here for the k is going to be your x value, which you need to know what it is. So you're going to have to graph it separately for the second part of the graphing. So on your TI-84, hit graph. Y1, you're going to be inserting. Okay, well, that's just weird. Let's try this one more time. So you're going to do Y1, which is then going to equal to this equation right here. Y2, you're going to type in 9.8757. And then, of course, hit graph. So on your graph, you should have a picture that looks something like y equals 9.8 is going to be this line right here. So y equals 9.87 or 9.88. There we go. And then this equation right here, when you do graph it, is going to look something that looks like this part right here. And your goal here is to find the intersection of it, which is at this point right here. So at this point right here, your x value, you know your y value is going to be 9.88, but the x value is going to be 2.497. And so your k is going to be 2.497. And that is your answer. All right, you guys, so that concludes the 4-part of the questions itself. So in addition to that, I do have a video that I would like you guys to watch, especially if you're taking the AP exam. This kind of goes over the security aspect of the test for you guys. It's released from Princeton, from the Princeton College Review. So just on YouTube, you can just go ahead and type in what you need to know about cheating and security on the AP exam, spring 2021. And then from there, make sure you use this URL right here or the QR codes to go ahead and answer the following 4 questions. All right, as always, I hope you have a wonderful week, and I'll see you guys next time. Take care.